Okay. Better? Let's try that. Okay. All right, I'm going to be doing a lot of typing. So, let's make a variable people, right? Let's say it's a list of person, right? By the way, this is Scala syntax for the equivalent of this in Java. It's just generics. Let's say we just have a list of people. What's a person? What's a person? Right, let's say it's a person. We have a name and an age. Okay. Then let's say the person has a list of addresses. Okay. What's an address? Right, let's just say street, string, zip, int. Okay, fine. Now, let's say we have a list of people and we want to know all of the street names of all of the addresses. Okay, how do we do that? Well, typically the way that we do it is like this, where, let's say Java will have val street names is going to be some array list of string, and we're going to make like a new array list, blah, blah, blah. All right, then what are we going to do? We're going to say for p in, for p or in, or whatever the syntax in our language of actually doing this is in people, right? And then we're going to say, let me actually change this. Whoopsie. Change this and change that. And then we need all of the addresses. So again, for a in p dot addresses, right? And then street names dot add a dot street. And this wonderful pattern continues. Let's say we have people in companies. So for, let's say, C company, right? Let's say we have a company class, right? And that has a name and employees, blah, blah, blah. So we just continue this wonderful pattern here. All right, and then this is going to be c.employees, right? And let's say a company is located in a country, right? And that has a name, companies, and that has a list of company. So again, we repeat this wonderful pattern. CO in, let's say we have a list of countries. List of country. Right, and then we have this in countries. Okay, so we're already starting to build this giant pyramid. And let's say that we want something simple like, oh, all the FACTA countries and all the public companies and all the people who have reported their tax returns. Okay, all right, let's go. If co.isFacta, if we're lucky, the API is that simple. All the public companies, if c.isPublic. And then let's say, what did we say? If let's say all the full-time employees. All the full-time employees and all of the companies that are public in all of the FACTA countries. How many levels deep are we? 1, 2, 3, 4, 5, 6, 7, 8. Why are we 8 levels deep? We're not trying to do something that complex. We're just taking all of the full-time employees and all of the public companies and all of the FACTA countries. This is not like that crazy. Why have we built up this gigantic structure for it already? So, okay, let's step back for a second. Let's look at a simple case. Let's look at the simple case that we started with. For P in people, or let's just start with addresses. Let's just assume we have a list of addresses, right? And we just want the street names. List of string, new, array, list, whatever, blah, 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 blah. Okay. Right, street names dot add a dot street. This is 4 lines of code for literally what are all the street names in this list of addresses. This takes 4 lines of code just to do that. Can't we have reality which is simpler? Well, most languages have reality which is simpler, which is this. Street names equals to addresses dot map. A to, right, A is an address, A to A dot street, right? This is a lambda function. So the map operator allows us to pass this lambda function in, and out we get a list of street names, right? That's relatively simple. And in a lot of languages, we can just do that because we have type inferencing. In certain languages like Scala, we can just do that, but in JavaScript, it looks something like that. Now, typically, oh, by the way, in Java, it's going to be something like that. Right? This is going to be in Java. Oh, and also in Java, you need to do dot as or to stream, and then you need to do dot collect. Something like that, and you need some collector function. This is what it's going to be in Java. In JavaScript, it's going to be approximately this. This is what it's going to be in Scala. Okay, so street names, again, is a list of string. But now let's say we need to go 2 levels in, right? Now we want to go 2 levels in. So we go 2 levels in. Well, now we start getting an issue. Let's say it's going to be for P in people, and this is going to be p.addresses. So now we're 2 levels in. Okay, well, let's see what we can do, right? How do we do the equivalent? Can we have a one-liner for this? Right? Can we have a one-liner for this? So okay, so let's start. Let's say street names, or let's say output, and then let's say people.map. Let's say people.map, and then, okay, let's just say we want all the addresses from each person. Well, if, let's say people.map, or this is, let's say p, let's use the variable p. Okay, now if p.name would give us a list of string as the output, what is going to be .map to addresses? And let me actually just quickly copy this, right? Okay. You do a map from a person to a string property, you get a list of string. You do a map from, let's say, age, you're going to get a list of int. What's it going to be if you do addresses? Yes, list of lists. Right? List of string, right? That's pretty simple, right? Imagine you had some foo property whose type was foo, right? When you do that, that's foo, right? Foo, this is going to be foo, right? Foo can happen to be, if foo is a list of bar, right? Just plug it in, right? So that's what it's going to be. There's no intelligence here. So if we want to get from people to addresses, we need to flatten out the list. So that's why we have another operator called FlatMap. And that's it. This is the whole talk on one foot. You know, if anybody wants to leave now, this is the whole talk on one foot. So we need the secondary operator to FlatMap into addresses. But once we've done that, we have, sorry, this is going to be a list of, list of address. Sorry. And this is going to be list of addresses, right? Okay. So, excuse me. All right. So we flattened it out, and now once we have, oh, by the way, by the time we're here, this is already a list of addresses. At which point we can do .map, and this is going to be address to a.street. Right? We can do that. So let's actually take this whole line. Let's copy this. Right? And then we map to a.street. And this is going to be string. So we did it. In one line, we have all the street addresses of all of the people. Well, yes, I'm cheating. I'm cheating. I am here to teach you how to cheat in a sophisticated way. Yes, it is a form of cheating. Yes, chaining is a form of cheating. But this form of cheating works extremely well. Right? So let's say we have something like this. Let's take out the ifs for a second. Let's pretend that that doesn't exist. And let's pretend that this doesn't exist. And let's pretend that this doesn't exist. Okay. Oh, we can just delete them. Okay. So let's just have those. Well, what do we do if we start with a list of countries? List country. Well, what do we do? All right, let's go. Countries dot FlatMap, CO to CO dot company, dot FlatMap, company to company dot employees, dot FlatMap. This is going to be a person already, to addresses, dot map, A to A dot street. Right? And this is going to be a list of street names. And there it is. Okay, this is a bit of a long line, but we have done this. We have done this in one line. And, huh? Let's go. All right, let's go. Let's do this. Let's do this. Is it shorter? All right, they are of equal length. They are of equal length. Yes. Oh, that's right. That's right. We don't have the vowel declaration. Okay, we can compare it. Yes, it's shorter. Yes. It is comprehensible. It is comprehensible on one line. Yes, absolutely. Okay, let's rewind. All right. So, ta-da, 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 ta-da. Oh, but wait a minute. I can see a potential problem. What if this isn't, what if you want street names, but what if, this was, by the way, this was an array. Let's say, well, immediately I can see one problem, which is this. Let's say if we want to know the street name and the name of the person concatenated with a dash. So, Joe 123 Street, right? Like that. Okay, well, inside we can just add p.name plus the street name. But how do we do that here? We don't have the person by the time we go here. Or let's say we want something even more interesting, like we want the country name, like USA-123 Street, right? We certainly don't have the country name, right? We don't have the country name in here. So what do we do? There we go. Let's we go back to this and we ask for another 4 months. Well, as a matter of fact, what we can actually do is we can nest these things one inside of another. So here's what we do. Right? This, we just put that in there. And this, we just put that in there. And this, and there we go. Right? We just put them one inside of another. And then, by the time we are here, yes, this variable still does exist, because we have put them one inside of another.
Are you back to square one?
Huh?
Are you back to square one?
Well, let's compare. This versus this. Are we back to square one? Now, let's try something else. Let's try adding back the filters. Let's try adding back the filters. Okay, how do we add filters to this? Okay, well, this is a list of companies at this point. Okay, so we can just use a filter. Oh, this is a list of countries. Let's start there. Filter, country to C dot is FACTA. Okay, company to filter. Sorry, this is whatever. It doesn't matter what we declare the variable because it's a separate thing, but okay. Filter, C to C dot is public. And then let's say person, employees, filter, P to P dot is full-time. Okay, so we added 3 filters. So we are how many levels deep? 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5, 6, 7, 8. I think this is still a little bit better. Maybe? No? Huh? Oh, that's perfect. That's perfect. So is FACTA, we put it in there. And that we put, hold on, is FACTA, and then that, and then that, and then, hold on, is public, company dot is public, and employees dot is full-time. Employees dot is full-time, okay. Is that better? I don't know, that just looks strange to me. So I think this is reasonable. It's not perfect, but it's reasonable. Of course, there is another trick. There is another trick if your language supports it, and this is iffy, but for example, the other thing that you could do is you could actually pass the employees. In each one, you could pass the company and the employees. And you could actually pass, and in here, you can actually pass the company, the person, and the addresses. And you can technically, right? And then by that time, when you're here, you're going to have when you're here, you're going to have the person as well as the company. And then by the time you're here, you're going to have the person, the company, and the address. Again, this is more complicated to write if your language doesn't have tuples, but you can technically pass them all along. And there is a language that you don't have to do this explicitly in, but there is a language that kind of does this behind the scenes that I will explain in a second. But okay, this is like reasonably decent, at least I think. It's a reasonably decent alternative for a giant pyramid that looks like this. Again, in Java, the fact that for every single one of these you have to do toStream obviously makes it a more difficult thing. But which is why in Scala what we have is this. We have this thing. This is not a for loop. It's called a for comprehension. And what essentially it does is this. CO is going to be that. company. C is going to be that. P is going to be that. And then finally, this is going to be p.addresses. And then we can actually do this. And so in Scala, actually this is syntactic sugar for this. And by the way, you can actually even go to even better syntactic sugar, which is you could do this. That. So this if thing is a syntactic sugar for this. Sort of. Actually, it's an alternative, which is with filter, but it's lazy as opposed to eager, but details. Basically, this is syntactic sugar for this. So this compared to this. So this is where we're going. This is where we're going. Now, okay, Scala has a construct that looks like this. Now, C#, believe it or not, has a equivalent construct. In C#, the construct looks a little different. In C#, the construct looks like this. From countries where as CO. We're getting there. We're getting there. From co.company where as C. From c.employees where as P, or c.employees where P. Oh yes, we actually have to. Oh, I'm sorry. These. Excuse me. These actually go not here, but there, I believe. From p.addresses as A. Select. There's our SQL. So this is the thing in C#. This is essentially the syntactic sugar in C# for something like this. Oh, and by the way, instead of FlatMap, there is a equivalent unsyntactic sugar in C# where this is going to be select many. This is going to be select many, select many, select many, and this is select. So in C#, oh yeah, so I'm pretending that the filter is the where. So yes, so this is called link, or language integrated query in C#, and it has an equivalent thing for where. Link is actually very powerful. You can also do group by and link, and it has equivalent syntactic sugar for group by and stuff like that. Now, by the way, remember how I mentioned this? The syntactic sugar of this in C# is actually something like this, and you could look it up. It doesn't have a nested set of flat maps or select manys. It actually secretly, very quietly propagates all of these variables behind the scenes. So you can read about this, but this is actually gives you much faster compile times for C#. So this is the equivalent. This is the equivalent of this kind of for comprehension. So this is a way of dealing with collections, but it is a way to deal with more than just collections. Let's go to something completely unrelated. Let's go on to something different from all of this. Let's talk about JavaScript. So let's talk about I don't know who was around and did JavaScript like back during the jQuery days when we were first building Ajax and callback handlers. Let's look into a little bit. Let's look into that. So let's say we want I'm sorry? The good old days, right? So let's say we want to get a list of people. Okay. There's going to be a get call. We have some URL people API / people whatever, right? So people, and we start with an ID, right? We start with some kind of integer ID, right? And we have some kind of ID that we pass inside. Okay, something like that. Okay. Well, again, we need async because JavaScript doesn't let you sit around and wait for the callback, right? Val person, you can't do that, right? You can't do that. In fact, you don't have types in JavaScript. But so what do we do in JavaScript? Well, we have this wonderful little object that we pass in, and we have this JSON object. We have success, which is going to be a function. And that's going to have the result, and then we're going to have a code, and that's going to be the success handler, and this is going to be on success, and this is going to be on failure, and we're also going to have a function that's going to return the code. All right, and then let's say we want the person's tax ID. So then what we do is we take the result and we actually say, let's say var person is going to be JSON.from JSON result. And then we're going to be able to say, right, person.tax ID, and then we'll do something like document.getElement by ID, and we're going to put some ID in here. And then, or let's say we're gonna get element, and then we're gonna set the body or whatever by person.taxID. All right, then we're gonna handle the failure callback. Wonderful. So all of this is nice and great, unless you actually can't get the person's tax ID from one API call. Let's say we need some more data to get the tax ID, for example. Let's say we need to get the company they work at. And then once you get the company they work at, then you can query, I don't know, the IRS API call and get their tax ID from that. Okay, so what do we do? All right, well, rinse and repeat. We need an on success, and we need an on failure. Don't forget the commas. Oh yeah, this should give people like PTSD. Oh, and then what do we have here? Oh yes, the second API call is going to be companies. And then this is going to be person.companyID. Okay, and then we have this is going to be company, and then JSON.from JSON result. Oh, and then we need to make one more call. Let's say we're calling the IRS database now to get, and then once we have the company now and we have the person, and so now we can get their tax ID. Let's say tax ID, right? And then we have person dot, let's say company dot let's say tax ID, and then we have person dot tax ID, and then again and there and there and there and there and there, and then and then finally we can do whatever we're going to do with this. So this, so again, JSON, what did we say? Var tax ID is going to be json.fromJSON of result document.getElement by ID #123 tax ID dot ID or whatever. Okay. Again, this is not, what we're doing here is not that complicated. We just want to get a person. We want to get a company. We want to get the tax ID using those two pieces of information. Why do we have to do so much? So this is a known problem in JavaScript. This is called the pyramid of death, because your code moves from left to right faster than it moves from up to down, which is sort of kind of similar to what we had here. Surprise, surprise. Okay, so all right, let's say, for example, let's try and like reason about this in slightly simpler terms. Let's say that we didn't have to do this to.json stuff, and we actually did have typing. Again, I'm just going to hand wave here a little bit. Let's say person, and here we can do some magical thing where we like pass in the person template and it does some kind of automatic conversion. And then here we could do company, and then this is going to be company, and then here we could do, and then here we could do, and then here we could do tax ID, and this is just going to be tax ID. And let's say we can just magically do this. So, okay, next. Well, we're still building up this pyramid of death. So let's say we had the notion of a promise, or a callback, or something like that. Right? Future person. Huh? Or a promise object. A promise object that uses a callback. So the idea is, okay, we have this future person. Let's just go on one level. Let's just try and start with one level where we just have this. And then let's say we have a on success, right? On success, on failure, right? Let's just say we want to return the person's tax ID. Okay. So, okay, val tax ID. Okay. Well, if we have a way to do this, right? This is going to be future of person, right? If we have a way to do a future of a person, then we need a way to get a future of a tax ID. Let's actually even make this simpler. Let's just return person, right? Future person, right? Let's say that we have a future person. Somehow we want to have a notion of a future person that doesn't require us to have a callback. So if we could just return this whole thing, somehow, if we could return an object onto which you could basically say sometime later on success, on success, let's say we can do something with the person, right? We want to return something like that. Well, okay, if we could handle, and then let's say on success, let's say, or do something with this person, do something with P. Okay, if we had something like that, well, failure we can typically handle with some other channel. But if we could do something like that, if we had a way to return future person, and this was some kind of future object that we can then do something with, for example, okay? Well, at that point, we kind of, well, this is really, and we usually don't care about the code, which is the URL code, so this is just this, at which point it's basically this, at which point it's basically this, and basically this, and basically this, and this isn't necessary, and this isn't necessary, and this isn't necessary, and this isn't necessary, and then it's basically this, and it's basically this, and it's basically that. Okay, and this is going to be a get, and then And then on success, it just goes down to that. We kind of have eliminated this entire pyramid if we can have this get call return a future object. Okay? And then we can do something on the on success. But wait a minute. We still have a problem, right? This, let's say we have a type for this. Let's call it future or promise or something. This is going to be future of person. What if we need to do a second call? What happens if we need to do a second call? What happens if we need to do the get company? Right? Let's say we need to do that. Right? So we do on success. So on success, before we did that, this returned us, well, what is this going to return us? If we do something, let's say this is going to be, do something. Let's say we need to append it to the element, and we need to get the previous value of the element, and then we're done. Right? Well, the previous value is going to be, let's say, append and get previous value. So this is going to be an int. So what is this going to return a future of? So this just appends the new person object to some DOM element and gets what was there before, which is like, let's say, the previous value. Let's say the previous value was a string type, right? This is going to be future of string. Okay, well, if we try it now, let's try chaining a second web call here. Let's try chaining a second web call here, and this is going to be dot on success, and then inside of here, we're going to say P2, and then we're going to put our second callback. We're going to put our second callback in here. So we started with person. We're going to get a company. Okay, so this over here, this was future of person, right? This was future of person. Then we called on success, right? This is the same thing. We called on success of future of person, and now we're getting a company. And this is going to return future of company, right? Because, again, we're returning future objects. So then, what is this going to be? If future of person, and then we just did this, or let's say something even simpler, right? This was future of string, right? So we had a future person. We called on success. We did future string. That gets us a future string, okay? But what if we make another callback, and that returns a future company? What is this going to be a future of? Let's say we didn't get a company in here. Let's say we returned 1, 2, 3, right? This would give us a future of int. Okay? But we're not returning future of int. Yes. Okay. So we're at the same problem that we were before. We need a way to flatten these things. On success is another fancy name for map. This is just map. What API call do we do when we need to flatten the result of a map? Smush, or, yeah, smush, right? We just do that. Okay, so we call FlatMap, right? And that's going to smush it down to future of a company, right? And we can just rinse and repeat, right? FlatMap. And this is going to be company. And then we're going to have tax ID. Or, yeah, way too high. Yes, right here. There we go. Tax ID. right? And then finally inside of here we can map. Okay, so then we have the result. We have everything we need to do, and we could do this thing, whatever. And this is going to be the future of whatever was, let's say, in that DOM element before. I don't know. At this point, we don't really care about it. We can just return this thing or whatever. So this thing is gonna do what it's gonna do, and then it's gonna get done. And so that's it. We did it. And so if we want to, if you want to put in the whole thing, it's going to be this. And again, if we have this wonderful syntactic sugar of a for comprehension, well, then it looks like this. Da-da-da, da-da-da. Right? Okay. So here's where we're at. Oh, by the way, all right, this is where we were at in the beginning, approximately. Right? So here's where we were. Here's, right, we're trying to get to something like this. So we're flattening the pyramid. So this concept of mapping and flat mapping and the result of the syntactic sugars allows us to flatten these pyramids. And by the way, if we're doing something like C#, C# has tasks. So again, in C#, the equivalent would be from blah, blah, blah as P. And you can do something like this in C#. From as C, from as T. Select. Okay. And so this is the usefulness of map and flat map. It allows you to do things. It allows you to do things in a flat way, things that are nested, typically nested. And languages like Scala, like C#, and there are some others that have special syntaxes for handling them, allow you to do very nasty things in a radically simpler way. Now, it is 8:58, so I can either go into SQL if anybody wants, or I can wrap up this talk. Where's everyone at? I can do a short thing of SQL, or I could finish up. What does everyone want? Okay, the wrap up is also 5 minutes. So, all right, let's. 5 minutes or 10 minutes? We need to be precise here. Okay. I was going to for half a second. I mean, okay, we'll do. I will spend 5 seconds on SQL. Okay, let's spend 5 seconds on SQL. Remember how we said, let's say people dot flat map p2 p dot addresses, right? So this is returning the addresses in each person. But let's say we don't have a list of addresses in each person. Let's say we have a list of person. And then let's say we have a second list of all of the addresses in the world. And the only way to join the people to the addresses is this ID, people.id, equal to address.person_ID. So we have a list of people. We have a list of addresses. The list of people contains all the list of people in the world. The list of addresses contains all the list of addresses in the world. And the only way to know which person has which address is by this ID thing. This is the definition of SQL. This is SQL in a nutshell, right? We just happen to call it table or query or whatever. But this is the definition of SQL. Okay, so how do we work with this? Okay, for P in query of address. right? We have to have some kind of construct to construct it. Okay, query of address. A in query of, P in query of person, A in query of address, if, oh, right, what is that equivalent to? Select star from people, or let's say person, where, person address, person P address A, where this. Where that. Oh, let's say we just return yield P person address, right? Select star. Okay. Oh, but wait a minute. We typically don't like to do it like this. We like to join, right? We like to do joins. Okay. Right? We don't like to do it like this. What we actually like to do is we like to say join address on that. We like to join addresses on that. Okay, so we have to do .join instead. Okay, we're joining. This is SQL. This is all of SQL in a nutshell. Oh, but wait a minute. What if we take this join statement out? What if we take this out? What do we call this? What do we call this? In fact, what happens if we take this out? What do we call this? What are we doing here? What is this called? Cross join, full join, right? So every single join in the world is just a filter on a cross join. Oh, by the way, what is this syntactic sugar of? This is just query of person dot FlatMap to P of query of address dot map. Oh, okay, fine. We need something. People addresses. Okay. Actually, we kind of don't even care about this. So that's a cross join. Flat mapping and cross joins are kind of the same thing, right? We typically say that that SQL. Oh, by the way, we had a filter, or a join function, right? A join function, right? We had join a to a dot id equal to person, address dot owner, or person id equal to person dot id. Okay, we have this filter here, right? And then so we just put this thing in right here. Okay, we just put this thing in right here. It's just, this is the definition of SQL. SQL is just one table joined to another in a flat map-like structure. Now, okay, we say SQL is declarative, right? This is declarative, right? We say SQL is declarative, right? Join address A on. Okay. Is this declarative? Yeah. Okay. Is this or let's say this. Is this declarative or imperative? Imperative-ish? Is this declarative or imperative? Lambda's imperative? Who says lambda's imperative? What if this was instead of address A, what if this was an arrow and this was a lambda? Would that be declarative? Bottom line, declarative, imperative, these are concepts we thought of in our minds. They don't exist. They don't actually exist. Like, we thought in our brains, oh, this is declarative, that's imperative. These are not real things. This is just something we made up to understand the world. Okay, let me wrap this up very, very quickly, since we are substantially over time already. Let me just wrap this up. So we saw three things. We saw query of person. We saw query of person. We saw list of person. First we saw list of person, then we saw future of person, right? Then we saw query of person, right? Okay. And we saw map and flat map. Okay. We saw map, right? What did map take when we were doing our stuff up here? right? What did map take? This was our map, right? It took a function. Okay, so it took a function, address, right? We took a function, we went from, or this was addresses, so this was address, right? We went to string, so this was a, address to string. And this yielded a list of string. FlatMap was more interesting. We went from, right, this was people.flatmap p2p.addresses, right? And this yielded a list of address, okay, right? So each one of these was a list of address, okay? So each one, this was a list of addresses that we yield. So in here, each address, for each one we returned a list of addresses and a list of, so this was address. So this was from person to list of address, and it returned a list of address. Okay, so that's map and FlatMap. Right? Oh, and we can give them letters, right? If this is T, and this is going to be T, which is the input, and this is going to be T, and this is going to be the output in this case. This is going to be R, 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 this is going to be R. Can you take a guess how these two are going to look like? They're going to look exactly the same, right? They're going to look exactly the same. Ah, except one difference. What is the output of the future map going to be? Ah, future. Future, future. What about query? What is the output of map, of flat map and query going to be? It's not going to be future. What's it going to be? Query, query, query. Okay. Now let's invent an imaginary data type called FlatMappa. FlatMappa. Okay. What's the output type of FlatMappa going to be? FlatMappa. FlatMappa. FlatMappa's everywhere. Okay. Oh, this is going to be T, by the way. Okay. FlatMappa has a name. Monad. That's it. So this is a pattern. This is a pattern that you see in SQL. This is a pattern that you see in reactive data types, futures, promises. You see it in lists and collections. This is like a super pattern that you just see everywhere, that you see in all of programming and all of the different parts of programming, and it all just follows this pattern. The rest is commentary. That's it. Oh,